Alright guys, so this lesson is going to be over Cpctc, which a lot of you were asking me about on the quiz review, and I told you don't worry about it, it's not on the quiz, we're going to do it tomorrow. So, what does it stand for? It stands for corresponding parts of congruent triangles are congruent. So this is where the Cpctc comes in. We have your C, P, C, T. C. There we go. And again, you know, this kind of makes sense once you read it. Obviously, if these triangles here are congruent, angle B is going to be congruent to angle F, A is congruent to D, C is congruent to E, AB is congruent to DF, and so on and so on. But in a proof, instead of writing this phrase every single time you need to use it, you can abbreviate it to Cpctc. It will always come, and we'll make a note here, it is always at the end of a proof. So before this lesson, we had side, 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 angle, side, angle, side, angle. That would be at the end of the proof because we were just proving the triangle's congruent. Well, now in our proof, if you look at the example below here, we are not trying to prove the triangle's congruent. We're trying to prove two pairs of angles are congruent. So when we do that, before we do that, we have to prove the triangles are congruent. So this justification over here may be side, angle, side, 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 whatever. But the justification for the last one is always going to be Cpctc. So, and then just to fill in the other blank, to show that corresponding parts of congruent triangles are congruent, just show that the triangles are congruent by, and again, we have 5 ways. So, side, angle, side, angle, angle, side, angle, side, angle, HL, and side, side, side. So those are all the possible ways we can prove the triangle's congruent, and then after that we're going to use Cpctc to prove that one of the corresponding parts is congruent. Maybe we have an angle that we want to prove congruent or a side. So for example 1 here, we have these two triangles congruent, and again, if you were to list out the congruent parts, we have angle A congruent to angle D, B is congruent to E, and C is congruent to angle F. And then with the tick marks, we have AB is congruent to DE, AC is congruent to DF. And again, I'm reading down here just to make sure because the triangles are flipped. So we have AB congruent to DE, that's how I know. And then BC congruent to EF. So proof number 1, let's go ahead and get started. And this is the only one I'm going to do in the video, and then tomorrow we'll do a couple on the next page. And then for the rest of them, they are all 2-column proofs. You will get plenty of practice. I am going to work on getting banks for you guys, reason banks, statement banks, and I'll have a whole list of those that I can put at each group tomorrow. So for this proof here, we're given that PQ is congruent to QR, so I'm going to go ahead and mark it on my picture, and I hope you did that on the quiz today. PS congruent to SR. Pause for effect. Honey, get out. I'm videoing.
Your eggs are boiling.
Okay.
Can you take them off?
Yes, please. All right. And we have the side down the middle that we can put a marking on. All right, so the first statement, justification is given. Second statement, justification is given. A lot of the times, and I think on all of these proofs, they are going to put given on 2 separate lines. I know when I do it to shorthand it, I always put all the givens on 1 line, but you're probably not going to see that anymore, especially if the proof is laid out for you. So, number 3, we have QS congruent to QS. Hopefully you've memorized the justification for something like this by now. That is the reflexive property, or ref poc. And then if you look at the picture here, why are these triangles congruent? Well, we have no angles, we have nothing but sides. So we're going to have S, S, S. And then the last justification, we want to prove that angle PQS is congruent to angle RQS. So angle PQS is right here. Angle RQS is right here. And those angles are congruent because they are corresponding parts. And again, we've already proven the triangles are congruent. So by Cpctc, all of the corresponding parts are now congruent, not just the sides that we know. So we have these two angles are congruent. That's what we're trying to prove. So last justification is Cpctc. And we could also prove that angle P is congruent to angle R by Cpctc. And we could prove that angle PSQ is congruent to angle RSQ by the same method. So that's all I have for tonight, and I'll see you guys tomorrow.